July 16th, 1945. The desert of New Mexico was silent. No crowds, no warning, just a group of scientists waiting for a moment that would change the future of humanity forever. At exactly 5:30 in the morning, a blinding flash lit up the sky, brighter than the sun itself. In that instant, the world entered the atomic age. The man leading this historic experiment was a physicist named J. Robert Oppenheimer. That explosion was not a weapon used in war, at least not yet. It was a test, a secret experiment conducted deep in the desert. Scientists had built something never seen before, the most powerful device humanity had ever created. Their goal was simple, yet incredibly dangerous: to prove that splitting the atom could release an unimaginable amount of energy, and they succeeded. The explosion produced a massive fireball, hotter than the surface of the sun, and a shock wave that traveled for miles. From that moment on, warfare and human history would never be the same again. But how does an atomic bomb actually work? At its core, an atomic bomb relies on a process called nuclear fission. Inside every atom is a tiny center known as the nucleus. Normally, that nucleus is held together by an enormous amount of energy. But when scientists split it apart, that stored energy is suddenly released. And not just a little. A single fission reaction can release millions of times more energy than a normal chemical reaction, like burning fuel or exploding TNT. But the real power of an atomic bomb comes from something even more dangerous: a chain reaction. This is where things become unstoppable. Atomic bombs require special materials, heavy elements that are naturally unstable. One of the most important is uranium-235. This isotope is extremely rare. In natural uranium, it makes up less than 1%. But when a neutron strikes a uranium-235 atom, the nucleus becomes unstable and splits apart. When that happens, three things are released: energy, fragments of new elements, and more neutrons. Those new neutrons strike other atoms, and then more, and then more. Within a fraction of a second, billions of reactions occur one after another. This unstoppable sequence is known as a chain reaction. Building an atomic bomb was not just a scientific challenge. It was one of the most complex engineering problems in human history. First, scientists had to separate the tiny amount of uranium-235 from natural uranium. That process required massive factories, advanced machines, and enormous amounts of electricity. Then came the most dangerous step: assembling the material. If the amount of uranium reaches a level known as critical mass, the chain reaction becomes self-sustaining. But if it exceeds that level, something called supercritical mass, the reaction grows out of control, and the result is an explosion, an atomic bomb. Inside an atomic bomb, scientists keep the uranium in separate pieces. When the weapon is triggered, a conventional explosive forces those pieces together. In a split second, they form a supercritical mass, and the chain reaction begins. The energy released in that moment comes from one of the most famous equations in science: E equals mc squared. This equation shows that even a tiny amount of mass can be converted into an enormous amount of energy. In fact, less than 1% of the material is transformed into energy, yet the result can destroy an entire city. The concept of the atomic bomb may sound simple, but its creation required decades of research, thousands of scientists, and some of the most advanced technology ever developed. Yet the true impact of the atomic bomb is not measured in physics. It is measured in human lives. Because once humanity unlocked the power of the atom, the world gained a weapon capable of destroying itself. And that reality still shapes our future today.